So good evening everyone. This is Hajera Maa'm taking organic chemistry. So we are in general organic chemistry. In the previous class we were talking about isomerism, that is geometrical and conformers. And today we are going to continue the little bit of the isomerism 4, and we are going to talk about a new topic called as cleavage. So in this we'll be having concept tips and tricks and even PVQs with the solutions. Please follow us on sparkacademyonline.com, and you can join our Instagram page, Telegram page and Facebook page to get the latest updates. So you can join our daily classes, live classes, that is classroom or online coaching. We provide short-term, long-term crash course. This is a schedule for this year, where we have the classes right from Monday to Friday, and Saturday we don't have any classes, but we give the latest updates about the NDA and all related exams updates. So my class is from 5 to 6, that is organic chemistry, ma'am. You can join our classes to get 10% discount. You can use the coupon HAJ10. So make sure that you use the coupon to get the 10% discount. So coming to the session class, we have already started geometrical isomers, conformers. We are still continuing with the topic. That's why we haven't changed the session plan. So this was the topic which we have discussed in the previous class: geometrical isomers, conformers, calculation. Before we move on to the continuation of the part, we will discuss about cleavage. Then we'll talk about PYQs and as well as some practice questions. So let us talk about the new topic called as cleavage. After reading about or after studying about cleavage, we'll be having the questions both of isomers, that is stereoisomers, and as well as cleavage. So first is why we are talking about cleavage. Cleavage, this is nothing but breaking. Why we are talking about breaking? Actually, in a chemistry, that is organic chemistry, A reacts with B, gives C plus D. That means this molecules are combining, they are called as reactants. The one which is forming are called as product. You can see that the one chemical is changed into other chemical. That means whenever one chemical is changed into other chemical, definitely reactants will break the bond, and obviously the cleavage will occur. Definitely bond breaking will occur, and whenever they are forming the product, bond formation will occur. Hence, how the bond is getting broken, we are going to talk about under a topic called as types of cleavage, nothing but types of breaking. So we have two types of cleavages. One is homolytic cleavage, and the next is heterolytic cleavage. So what do you mean by homolytic? What do you mean by heterolytic? Homo, the name says equal. Lytic means cleavage. Here the equal cleavage occurs, whereas in heterolytic cleavage, hetero means different, lytic means breakdown. That means here the cleavage is different, unequal cleavage. Good evening, Bhavna. So we are continuing with the topic called as cleavage. Right, so we have two types of cleavage, homo and heterolytic cleavage. So what do you mean by homolytic? Simply, whenever two atoms are bonded to each other by having equal electronegativity difference, having equal electronegativity or no electronegativity difference, that molecules will get cleaved by homolytic cleavage. Example, we have an example here best. Cl2. The two chlorines are similar, whenever two chlorines are similar, you know, right, the bond will be in the center only, no one will take the electron. That means two atoms have no equal electronegativity or no electronegativity difference. The difference is zero, right? Or they have equal electronegativity. Difference is zero and they have equal electronegativity. Both are the same meaning. Whenever by any means a bond is getting cleaved, they will take their own electron. So whenever they take their own electron, you will get atoms having their one electron. That one electron I'm calling as unpaired electrons or free radicals. So that means whenever a homolytic cleavage occurs, free radicals will be generated. Now, so hope you got the meaning of this free radical, nothing but unpaired electrons, right? Moving on to heterolytic cleavage. What do you mean by heterolytic cleavage? Is unequal cleavage. Very simple. That means unequal cleavage occurs here. When atoms have electron negativity difference, E and D means electron negativity difference. Whenever atoms have electron negativity difference, they will get cleaved by heterolytically. Examples, consider like HCl I have. You know, two atoms are different, and you know chlorine is most electronegative element here, and it by any other means, if you know the bonds cleaved, you know chlorine will attract the whole electron, two electron toward itself. That means bond is cleaving heterolytically, and hydrogen is losing the electron and it develops positive charge, and chlorine will develop negative charge. The one which gains electron is known as anion. You know that. And the one which loses electron is nothing but cation. That means whenever heterolytic cleavage occurs, cation and anion will be generated. Whenever heterolytic cleavage will occur, cation and anion will be generated. Let us talk about an example related to the organic chemistry, because we're talking about organic only. Yes, H plus and Cl. Yes. So as we're talking about organic chemistry, so we should have an example related to carbon. Consider, you know, in the functional group we have discussed that carbon can be attached to heteroatom like chlorine, bromine, nitrogen, sulfur. You know that. Consider I'm attaching carbon to halogen, like I'm putting X represent the halogen. You know, carbon and chlorine has electronegativity difference. If bond is getting cleaved, chlorine will take or halogen will take away the electron, and if such thing occurs, heterolytic cleavage occurs, carbon will become positive charge and halogen will become negative charge. Now in this case, the thing which is matter to us is carbon attached to positive charge. That is nothing but called as carbocation. So in that case, we don't have a concern related to the negative charge, because our concern is with carbon. That's why I'm giving the name, that is carbocation. So simply remember, if carbon attached to electronegative element, carbocation will be generated. Now example, look here, one example where the carbon attached to electropositive element, like carbon can be attached to alkali metals or alkaline earth metals like magnesium, sodium. In that case, it attached to magnesium. You know, magnesium is S block, an electropositive element. Carbon is P block, electronegative element. Hence, in that case, electron will be tilted or moved towards carbon. Hence, in that case, you will get carbon attached to negative charge and magnesium having positive charge. In that case, our carbon is developing negative charge. It's known as anion. I have written here. So simply, bond cleavage can be any type depending upon carbon attached to which atom. If carbon attached to have atom having electron negativity or no electron negativity difference between two atoms, the bond definitely will be cleaved by homolytically and you will get free radicals. Whereas if carbon attached to electropositive or electronegative element, the carbon definitely cleavage is known as heterolytic cleavage, and carbon can be carbocation or carbocation depending upon electronegativity. Right. So this we have finished about cleavage. Simply I'm calling this as equal cleavage because they are taking their own electron. I'm calling as unequal cleavage because they are taking away the other's electron. So here Ions will be generated. Here, free radicals will be generated always. So please keep in mind about this. Ions can be cation and anion. Right. So with this we finish cleavage. We do have. So what I'll do here is I'll just summarize here one thing. If carbon attached to element which is having equal electronegativity difference, no electronegativity difference element, the homolytic cleavage will be formed, and what do we say, free radicals will be generated. If carbon attached to electronegative element, carbon will be carbocation. And simply, if carbon attached to any electropositive element, carbon will become carbanion. Carbanion or carboanion, both are same. You can write O, you can omit O, optional. So this is about the cleavage. Right. Hope it is clear. Moving on to the next one called as stability of reaction, stability order of reaction intermediate. What do you mean by reaction intermediate? Whether it is free radical, whether it is carbocation, whether it is carbanion, negative charge, whether it is positive charge, whether it is free radical. All these are definitely, any of this one will be generated during chemical reaction, isn't it? Because during chemical reaction, definitely one will be converted to other, right? If one chemical is converted to other, definitely bond will cleave. The bond can be cleaved by either way, like homolytic or heterolytic cleavage. That means any of these three will be generated. That is free radical, carbocation, carbanion. Okay. So these three are called as reaction intermediates. These three are called as reaction intermediates. Why they are called as reaction intermediate? Because they are formed during the reaction. So these three are called as reaction intermediates. Let me tell you that whether it is free radical, whether it is carbocation, whether it is carbanion, all these three are unstable. Whether it is free radical, carbocation, carbanion, all these three are unstable. So still what we have is, we have here stability order. So we still talk about the stability order for free radicals and carbocation and carbanion. So first thing is, I have the free radical stability order. So before we move on, let me just draw how many types of free radicals can be there. Just look here, I have got different free radicals. Consider there is some carbon here. If bond is getting cleaved, carbon will become free radical, isn't it? So we'll leave about the cleavage. We'll just talk about the stability order. Now you can see that here carbon got free radical upon cleavage, isn't it? Now look here, this carbon attached to how many carbons? R means carbon chain, right? R means alkyl group. Carbon attached to how many carbon? 3 carbon. This this free radical is known as tertiary free radical. Okay, because this carbon is tertiary carbon and free radical will be tertiary free radical. Now moving on to the next one. Carbon can be attached to only 2 carbon chain, right? This is tertiary, secondary carbon. Free radical will be secondary. Carbon can be attached to only 1 carbon. That is known as primary free radical. And the carbon can not be attached to any. That's why I'm just writing as only 1 carbon, which is known as methyl free radical. So we have got 4 free radicals here, tertiary, secondary, primary, methyl. We just need to look up which one is more stable. So what do you think, Bhavana, which one is more stable? What do you think which one is more stable? Don't look at the answer here. What do you think the most stable is? Tertiary one? Tertiary, secondary, primary, methyl. Let us see how it is most stable. Now look here, the concept is, as I already told you, that whether it is free radical, carbocation, carbanion. All these three are highly unstable. Consider all these carbons are having free radical are unstable. To stabilize this electron, one electron, you know what? As you know, right? Please remember always carbon chain R for alkyl group, nothing but carbon chain always is electron donating group, always is electron donating group. Hence this carbon is having one electron which is unstable. This adjacent alkyl groups are trying to stabilize it by giving it electron. So stabilizing is done by the adjacent three carbon group. That means there are three groups are there to stabilize this free radical. Hence you can say that tertiary is more stable because secondary has only two groups to give, whereas primary has only one group to give and methyl has no group to give. Hence the order of stability is tertiary is more stable than secondary than primary, because tertiary have three, secondary have two, and this primary have one, and the methyl has none to give. And the order is tertiary, secondary, primary, methyl. Hope you have understood this, and others who are watching. Moving on to the next one, that is stability order of carbocation. Let me just tell you the another name for carbocation. Carbocation means this nothing but having positive charge, right? Positive charge, positive charge, what do we say? Positive charge, you know that it has got positive charge means it is, attracts the negative charge. The one which attracts negative charge is known as electrophile, means attraction. Electro means electron, phile means attraction. That means the group which attracts electron is known as electrophile, nothing but positive charge molecules. Positive charge molecules. Because it is having positive charge, definitely will attract the negative charge, right? The one which attracts negative charge is known as carbocation, and the one which attracts positive charge is known as carbanion, because it has negative charge. You know that positive attracts. Hence, we'll talk about the carbocation stability order. Again, just consider there are four different types of carbocation: tertiary, secondary, primary, methyl. Again, the question is which one is more stable. Look here, it has got positive charge. It has got positive charge. So, what do you think the positive charge is having? Less electron, more electron? So positive charge means no electrons, right? Positive charge means no electron. No electron means it is unstable because it has no electron. That's why there are three alkyl groups which are donating its electron. There are three groups giving electron, and there are two groups giving electron, and there are one group giving electron. There are none group to give, and there are three groups means that's why the stability order is most for the tertiary, followed by secondary, then primary, then methyl. Hope you got the answer. Any doubts so far about carbocation stability? No? Now moving on to the stability order of carbocation. Anion means negative charge. It's also called as nucleophile because it attracts positive charge. Nucleus is positive charge. Moving on to the types. Again, we have four types as that of carbocation and free radical: tertiary, secondary, primary, and methyl. So you see, this is tertiary carbanion, secondary, then primary, then methyl. The question again is which one is more stable? Which one is more stable? So what do you think? Which one is more stable here? Now the question is, the sequence actually is here is ulta or reverse. Why? Because anion means having more electron, whereas cation means having less electron. So for positive charge to stabilize, we want electron donating group, and for negative charge to stabilize, we want electron withdrawing group. Now look here, in these cases there are three groups are giving. Already it has more electron, but still there are three groups are giving. it has already more electron, right, and was unstable. To dash and to stabilize, the molecule should withdraw, but there are three groups are giving. They are making more unstable. There are two groups are giving comparatively less stable. More stable, sorry, comparatively more stable in tertiary. There one group is giving, then no group is giving. So that means for negative charge we want withdrawing group, and for positive charge we want donating group to stabilize. But in negative charge there are three groups here which are donating, hence this is the least stable. Whereas in NEET style there are no groups are giving here, hence this is more stable. So please remember the stability order for carbocation and free radical is similar, whereas the stability order for carb anion is quite reversed. All the three questions stability order were asked in a JE mains. So we are going to do that in a short time. So please remember the stability order, please. That is tertiary, secondary, primary methyl for free radicals, similar for the carbocation, whereas ulta or reverse for carbanion. Please keep in mind about the stability order, because the three stability orders were asked in your JE mains. We are going to do just in a while. So before we start doing that questions, so please download our Spark Academy app to get this exciting discount. And I already told you that to get the 10% discount, you can use our coupon code, that is HAJ10. So there are many features that are available in our app. First is that the first and foremost thing is you can find our handwritten notes. You can find here that I'm giving my handwritten note here. Similarly, you will find there in this app, you will find the same free study material. You will find the PYQ question papers, and again the mock test on weekly basis. So to join our app, you need to click the link and you need to register. The link is in the description box. You can join our this year courses, and as well as the upcoming year, that is 2023 courses. For long-term courses, we provide the crash course, and even we provide the mock test. If you are thinking to join the mock test series, you can join our mock test series. We provide for all entrance exams like JEE Mains, NEET, Eamcet, IIT Foundation, and as well as for IELTS. As you know that we provide both online and offline coaching. We have already started crash course. Again, we are going to start one more crash course soon in the May. So we provide, as I told you, that NEET, JEE Mains, and Eamcet. Other features of our app is that you can get the videos available and live classes running. You will find the assignment session available for the students, and as well as stress session. After writing or after attempting the test, you will get the feedback analysis from experienced faculties. So the question is, why a Spark Academy? The answer is simply because we have highly experienced faculty in each and every subject, and we give personalized coaching to each and every student. And with our advantage, one more advantage is that our classroom is batch is very limited. That means we don't have the full students. We have the only limited students, so that we can focus each and every student. The methodology is very simple. We provide the concept right from the basic. Shortcut methods and all model question papers, exercise question papers, PYQs, which we are going to do just now after this, chapter-wise test, weekend test, grand test, and test analysis after your test. So you can join a classroom coaching and online coaching. Classroom coaching has advantage that you will get the classroom, as well as if you miss the classes, you can watch the videos that is online, that is available on our app. Whereas for online students, you don't have access to classroom and as well as books, but others features are available, can be accessible by online coaching also. So these are the questions which already we have practiced. I think we stopped in the intermediate. That the question was, the question was the alkene with exhibit geometrical isomerism, right? This was a question. We stopped everything. Let us continue with that, and as well as we have the questions about cleavage also. So the question is the molecule which shows geometrical isomerism. Do you remember the criteria for geometrical isomerism? You want a glance? So I'll give a glance, right? So the geometrical isomerism, the criteria was there should be restriction of rotation of bond. That means there should be double bond, and definitely whenever double bond is there, you will have 4 groups. The third criteria is very important. Out of all 4 groups, all 4 can be different, at least 2 can be different. This is the criteria. Let us just see which of the following option follows the criteria and shows geometrical isomerism. So in a question, in an exam, they can sometimes give you that which of the following shows cis and trans isomerism, or which of the following shows geometrical, or which of the following shows ZNE isomerism. So they can ask any of this question, but the meaning remains same. So please keep in mind about the concept. Let us just check which one suits our answer. 2-butene, I'll just draw the 2-butene. Means 4 carbon, ene means double bond. Where the double bond is at 2 position. Let me just draw. So there you can see that this alkene is there, restriction of rotation of bond. There are 4 groups attached. Out of 4, 2 are different to this carbon, 2 are to this different to this carbon. Hence the answer A for that. And you no need to, I think, go for that second, third, fourth, because it's already we found the first one. And if you want, please go to that also if you want. The question again is on monochlorination of 2-methyl butane. The total number of chiral compounds is. Let us just draw 2-methyl butane first, and they're telling that monochlorination. We need to add 1 chlorine to that 2-methyl butane. So this is online students who are there, you can answer the question fast. So this is 2-methyl butane. I want to add 1 chlorine to any, you can attach chlorine to any position. So what I'll do, attach here, here and here. I'll just see which one chiral is there. I'll start with putting of hydrogens here. So I got the 1 compound here. What do you think is the chiral compound? No, there is no chiral carbon here, right? Chiral carbon means carbon attached to 4 different groups. And this is not a chiral compound. They're asking how many number of chiral compounds is possible if you attach chlorine to anywhere if you want. So what I'll do, I'll just attach chlorine to to all carbons, and I'll just see how many I'll get chiral carbon. Secondly, I'm attaching chlorine here. So do you think there are any chiral carbons here? Do you think any chiral carbons here? This is a chiral carbon? No. This is a chiral carbon? Yes. No. Yes. The answer is this is a chiral carbon. At least I got 1. But there are no options for the 1. That means at least 2, 4, 6, 8 there should be there. Let us just check. Further more are possible. Definitely more will be possible because option says right. So what I'll do, I have attached chlorine here, I have attached here, I'll attach here, we'll see whether we'll get chiral carbon or not. Oh, chlorine I have to attach here. I don't think this is a chiral carbon, isn't it? This is not a chiral carbon. What I'll do, I'll attach chlorine here. We'll see what happens. Or here or here or here, anywhere, because both have the same CH3 group. I am finding no chiral carbon here, no, but I think this is a chiral carbon because to this carbon CH3 attached, CH to CH3 attached, H and C to C attached. That means I got the fourth and second is the chiral carbon. Maximum only I can do 2 only because I have attached chlorine everywhere, right? Here attach, here attach, here attach, here attach. You don't say that I should attach here because both are the same. That means I have possibly attach chlorine to every possible side and I got only 2. That means the answer is going to be 2 only. The answer is going to be A. So that means this was asked in JEE Mains 2004. So you see that question was asked. Let us now move to the next one. That is my next is what types of isomerism is shown by 2,3-dichlorobutane. That is AIEEE 2005 asked question. That means All India Engineering Entrance Exam. That is related to, that is nothing but JEE Mains only. So let us draw first to butane. Butane is like this. 2, 3 means there will be 2 second and third position fluorine is there. Complete the hydrogens. I have got here 3 hydrogens. I have got here 1. Got here 1 and here got a 3. So the question is which of this shows which one? Geometrical, there's absolutely no chances at all, because for geometrical I want, what do we say, double bond, restriction of rotation of bond. That means I want double bond. And for optical I want chiral carbon. I don't think this is a chiral carbon. Do you think it's a chiral carbon? Oh, so I think this is a chiral. Is it a chiral carbon? HCl. Yes, this is a chiral carbon. Structural, I don't think for structural the position should be different, hence structural also not possible. For geometrical we want double bond. For structure there should be change of chlorine position. That's not possible. So yes, the answer is optical isomerism because it should be chiral carbon. The answer is second or B. Right? Any doubts so far? Bhavna? Right. Then the next question is, which of the following molecule exhibits geometrical isomerism? This was a question asked in 2015 JEE Mains. So let us just see the options: 1 phenyl, 2 butene, 3 phenyl, 1 butene. But means 4 carbon, right? 2 butene, double bond should be here. 1 at phenyl is there. Phenyl means benzene ring. Let us write the hydrogens. So do you think that first one will show geometrical? Because we want restriction of rotation of bond, we want different group. The answer is yes, A will show definitely. Let's just check whether the second will show or not. That is second one. I got the first answer here itself. Let me just check with the second one. Why not this 3 phenyl 1 butene is not showing? Let me first draw the but, which is 4 carbon. And they are telling 1 butene means double bond should be here. 3 phenyl means benzene ring should be there at the third position. Complete the hydrogens. Oh, the thing is, second one, this attached to 2 similar groups. There should not be 2 similar groups. There should be at least 2 different groups to both sides. That means B will not show, C will not show, fourth one also will not show. The answer is A only. I have just checked why the second was not showing, and the answer is going to be the first one. Moving on to the question, the molecule which exhibit optical isomerism. Oh, optical isomerism they want. For optical isomerism, we want chiral carbon, right? We want chiral carbon. Let us just check which of the following will shows chiral carbon. So let me just draw the first option, that is 3-methyl 2-pentene. I first draw the carbon chain of 5. 2-pentene they are telling, I'll put the position here. 3-methyl they are telling. Here should be H, CH3. Here H should be there. Here H should be there. Here also have an H should be there. Here CH3 should be there. I don't find anywhere as chiral carbon. I got this no chiral carbon, no. The answer is not going to be A. Let us just check what about the second one. It's pent 5 carbon. Ene, double bond is at first position. Fourth methyl I got. Again I don't think I'll get the chiral carbon here. So nowhere I can find the chiral carbon. The answer is again not going to be B. Second. Third we'll check. Pentene. 1 pentene, 3 methyl, so I'll put the CH3 here, CH3 here, hydrogen 2 here, 1 H here, H here, H. So do you think this is a chiral carbon? No. This I find this is a chiral carbon. That means this is not a chiral carbon, but this one I found this as chiral carbon. Because CH3, C2, CH3, H, and this carbon is attached to differently. And the answer is going to be third one. Right. Which one is A? The answer is going to be the third one. Let us just check. Still we'll draw the fourth one. We'll see what happened. The fourth one. Sometimes in JMAs, there are certain, certain times we'll have 2 options available. Let me just check with the fourth one whether this shows chiral carbon or not. Pent means 5 carbon. Pent I got 5 carbon, 2 position where chlorine is double bond is there. 2 methyl is also there. I don't think again I'm getting the chiral carbons here. That means the answer is not going to be again 4. The answer is going to be the third one. Hope it is clear why the third one has shown optical isomerism, because it has shown chiral carbon. That's all. If they are telling geometrical isomerism, follow the 3 criteria. If they are telling optical isomerism, the criteria is simply that you need to find out the chiral carbon. That's all. Chiral carbon nothing but carbon attached to 4 different groups. Yes. D2. I think third answer. Let us go check to the other questions which are related to the free stability order, that is cleavage. The question is the increasing order of stability of the following free radical. Oh, they're asking free radical stability. What is the order of free radical? I think I discussed just now that the answer is simply free radical stability is tertiary, followed by secondary, then primary, then methyl. That means we need to check the one which is tertiary. Where the tertiary is there? See here, this is tertiary phenyl. Because this is secondary, so it will not be the answer. Here also secondary come in the center, which is not be the answer. But the question is simply the answer is going to be AIDS, right? This tertiary phenyl, secondary methyl. The answer is this. The next question is the order of stability of the following carbocations. The order of stability of following carbocations. So for carbocation, you just see here that there are certain different groups they are giving here, right? This is, benzene attached to CH2, 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 CH3, CH2, CH, CH2. We don't find here tertiary, secondary, primary. All this something different, right? Yes, please remember the carbocation stability. Okay, I have not written here. So what I'll do, I'll just write the one more stability order. Please remember that the stability order for carbocation is C6H5 taken thrice. That is triphenyl free radical is more stable than the diphenyl. Followed by phenyl, that is benzyl also you can say. This is triphenyl, diphenyl, phenyl carbocation, the stability, followed by tertiary carbocation, then secondary, then primary, then methyl, then allyl. Oh, allyl does not come much. It will be vinyl, then allyl. So what is vinyl group? Vinyl group is like this, ma. This is the first time vinyl is coming here. That's why I'm writing here. This is called as vinyl group. And allyl means vinyl attached to. This is called as allylic group. This is vinylic, and this carbon till here it is allylic. Okay. So now just look here. What do you think the stability order is? So I found here this here first. That is C6H5 CH2. That means third is going to the most stable. Then the anyl. Then this. That means the answer is going to be third one. That is this, this, and this. Right? So this is about the question which was asked in JMAs 2013 about the free radical about the carbocation stability. Please remember this is one more sequence which I have recently given you. So before we start to the more questions, before we start to the few other questions, please join our Telegram group where you can find the similar thing like our classes updates, test series, and our notes available on the Telegram group. The link is in the description box. You can click and you can join. So what I actually thought is, I thought to give you the questions, this questions in an assignment, but I think in the next week, that is Tuesday, we will not be having a class because that is the day we are having a Eid. So on Tuesday we will not be having any class. So what I'll do, I'll just discuss the key of the homework today itself. That is the alkene that exhibits geometrical isomerism. That was asked question in 2009. Propene 2-methyl propene, 2-butene, 2-methyl 2-butene. Let us just check which shows geometrical. Propane is, let us just draw the 3 carbon bond propene. H comes here, 1H and 2H comes here. That means, from this here, higher priority here. But in this case, there is no priority here. That means A or first is not going to be the answer. Second one is 2-methyl 2-propene. So I'll just draw. this definitely will not show, because this to this carbon, same group attached, again second is not going to be the second the answer. Let's just check to the 2 butene. In this case, to this carbon, I can higher priority assigned to this. In this case, higher priority to this again. That means I can assign the priorities to the both sides. That means C is going to, or third is going to be the right answer. Whereas again, I think if I find the third answer here, this is not going to be still the answer. Let me still just check the fourth one, butene, to butene and to methyl. Again, the answer is not going to be the fourth one. The answer is the third one. Hope it is clear why the answer became third. Moving on to the next question, that is number of stereoisomers possible for a compound for the molecular formula CH3CH double bond CH CCH Me. M represents Me nothing but methyl. Me refers to CH3 group, whereas ETH, this is a short form for CH2 CH3 group. So the question is, which of the molecule, like the formula they have given, and telling us to calculate the number of stereoisomers. Stereoisomers can be of two types, that is optical. I mean, three types are there. Definitely, we have number of possible isomers will for optical and geometrical only. So, what do you think? Does this molecule shows both optical and geometrical? For geometrical, they should be double bond. They should be 4 group attached. Out of the 4, 2 should be different. 2, 4 can be different. I think double bond is found here. That means it will show geometrical also. And optical के लिए we want chiral carbon. Do you think there is a chiral carbon here? Let me just check whether it has chiral carbon or not. Oh, the first one does not show. Second also no. Yes also no. I think this is going to be the chiral carbon, because here it is C OH they are telling attached. On one side CH is attached, and one side H is attached, one side CH3 is attached. This carbon which I am drawing here. That means this is a chiral carbon, and because of this carbon it shows optical isomerism, and because of this 2 carbon it shows geometrical. That means it is going to show both, that is geometrical and optical. Let us just check what is the answer for that. So what do you think? Do you want to calculate the number of stereoisomers? So this I'll just give you 1 minute. So please do tell me the answer for that. CH3 CH double bond CH CH OH CH3. So you have got what do we say, geometrical also, and you have got here optical also. Tell me the answer for that. A, B, 1, 2, 3, 4. I'm waiting. Bhavana, I'm waiting, and others who are watching, please answer the question. The second question, second homework. I hope you have got the formulas for optical and geometrical. Please just check back. Just check whether the ends are same or not. CH3 is here, Me is here. M refers to CH. That means both have the same ends. If ends are same, the formula is is with you only. So I'm waiting for the answer. Fast. Calculating. So still haven't got the answer. So we'll hold back this the second question. So what do you think about the third question? Then I'm expecting the second answer to be given by you only. So let us just go to the third question. What happened to the arrangement of carbanions? They're asking the arrangement stability order for carbanions. CH3C taken twice C, Cl3, CH3 taken twice CH, C6Fi, CH2 in order of their decreasing stability. So this is phenyl, carbanion, phenyl group attached. This is CCl3 attached to a carbon. Tertiary group is attached, and this is secondary group is attached. I think the answer is going to be the third one, because you see here in this case CCl3 carbon attached to 3 chlorine. I already told you that for negative electronegative element we want electron withdrawing group. There are 3 withdrawing group attached. That means this will definitely be the most stable. And you can see that here phenyl group is attached. Phenyl group is somewhat less stable. Withdrawing group. This is also a withdrawing group. But there are 3 group withdrawing group attached. This is 1 withdrawing group attached. You can see that this is secondary, this is methyl, because we have discussed that this is secondary and this is tertiary. We have discussed in a carbanion that methyl is more stable, methyl, then primary, then secondary, then tertiary. That means secondary is going to be more than tertiary. That means the answer is going to be the third one only. And I'm expecting the second question to be done by you only. Please upload the please write the answer in the chat box. Even after the class also, I'll just check the answers. Any doubts so far about this all? So let me just go back to the starting of the classes. We have discussed that geometrical conformers. I just wrote the criteria. I sum up all the criteria for the stereoisomers in the one side. You also do one thing whenever you're writing the notes. You also do write the criteria together for stereoisomers. It will be helpful for you. Also, and these formulas are very, very important. Yeah, so then we have discussed that cleavage, homolytic, heterolytic cleavage. Then after that, we have discussed the stability order for free radical carbocation, which is similar for both, whereas for carbanion, which is totally opposite. And in exams, they don't usually give R. They can give you anything, but the only thing you need to keep in mind that for stability of carbocation, we want donating group, and for carbanion, we want withdrawing group. Keep this in mind, the same concept. That's all. This kind of questions based on this donating and withdrawing group stability, they'll ask you in exam. They're asking in them actually in exams. So after that, we have practice certain questions. After that we have discussed the PYQs, and there are many PYQs to be kept, but we cannot keep in a 1 hour class. Go through the notes. After going through the notes, open the Eamcet book or JEE the NEET book, whatever the exam you are appearing for. I suggest you, even if you are appearing for Eamcet also, go through the JEE book. Even after you, even if you are appearing for NEET also, please go through the JEE books, and you also refer NEET PYQs. So you will be exposed to what kind of question they are asking in exam. So whether you for Eamcet, JEE and NEET, please practice the JEE mains questions, PYQs, even practice paper, and NEET pre-practice paper and PYQs. So that's all about the day. Hope you got all topics till now which we have discussed. So far, the 4 topics which we have discussed are nomenclature. Second one, nomenclature of hydrocarbons, and as well as functional group. After that, we have discussed isomers. Third one, we have discussed cleavage. After that, we have discussed about the stability order. We have discussed about the 4 things so far. And if you have any doubts in any of these 4 topics, please let us know, and we'll help you to understand the concept. So before we leave, please subscribe to our channel, press the bell icon for notification for the upcoming classes, and for the next week, that is Tuesday, we will not be having any chemistry class. That's why I have already done the homework for you, but I kept the one question for you, and I'm expecting everyone to give answers. So this is as highly experienced faculties. Thank you. Please don't forget to share, like and comment and subscribe to our channel. Thank you everyone.